All right, 1 2 mic check. Can you get me? All right. Good afternoon, ladies and gentlemen. Good evening. Welcome to another lesson with me, Aubrey. This is going to be a very interesting lesson. But even before we go into the lesson, I am requesting that you subscribe to the channel, hit the like button, hit the notification bell, comment on what you would like me to do in my next video, or would you like to see my setup. Comment in the video, and let's dive into the lesson. All right, today isn't so much of a teaching video. If you want to see me teach on this topic, you can comment. But one of my students asked me a question concerning this question number 7, and basically the question is on finding the harmonic conjugate. All right, finding the harmonic conjugate. For instance, you're given U and you're asked to find the harmonic conjugate V, or you're given V, you're asked to find the harmonic conjugate U. How do you do that? That is the question that I was asked, and mind you, we've done topics on harmonic functions with my students in physical classes. So if you want to see videos on that, you can comment in the comment box below. And yeah, and the next here is question number 11, where you are given the real part and you're asked to find the imaginary part and express it in terms of Z. All right, so these are the two things that I'm going to tackle in this video. So stay tuned. All right, so the first thing that we should know is that our function f of z is given by a real part u plus I and an imaginary part v. And we should also know that our function z, all right, I'll just write here, z has a real part and an imaginary part. All right, so now in this or let me say in this lesson, I'm just going to give you some formulas that you can use and how you can master those formulas, or how you can easily remember all those formulas. All right, so let me just clear down here so that I can write the formulas and tell you how you can remember them. All right, so as I have T-Pex that off, the first set of equations to find the harmonic conjugate V or U will be using the Cauchy-Riemann equations. All right, you should be familiar to the Cauchy-Riemann equations. That is the real part with respect to x, which is the real part over the real part, is equal to the imaginary part with the imaginary part. But when you have the real part and the imaginary part, this will be equal to the negative of the imaginary part over the real part. So this is how you can remember them, because remember, u is the real part and x is the real part. So when you have real part over real part, we're just going to have imaginary part over imaginary part, because these are imaginary parts. And when you have the real part and an imaginary part, so you have a real part and an imaginary part, this will be equal to the negative of the imaginary part over the real part, like that. So these two formulas, either of these formulas, will be used in situations where you are given u maybe as a product, or u as a quotient, okay? In a situations where you're given u or v as a product or a quotient, an example of a quotient is this one. You have u is equals to y over x squared plus y squared. This is a quotient, so you can use either of these formulas. This is an example of a quotient. An example of a product. All right, an example of a quotient is, a product is this one. Construct the analytic function whose real part is this one. All right, so we are asked to construct an analytic function whose real part is that. So the real part u is equals to e to the x then cos y. Okay, so that is the real has to find the imaginary part so that eventually we can put in the equation f of z equals to u plus iv. All right, so this is an example of a quotient. All right, so if you would like me to share the entire tutorial, you can just comment that in the description and I will, or in the comment box, then I will share the tutorial in the comment box. So the first situation is where we have quotients or product, so we can use either of the Cauchy-Riemann equations. And the second scenario is where we have a function that is connected by plus or minus and so on and so forth. So whenever we have a situation where a function is connected by a plus or a minus linearly and we're asked to find v or u, you will use this formula. All right, let's say in this case you're asked to find v. You're asked to find v, as you can see here. You're asked to find v. Okay, so we are going to say v, okay, is equals to, what is dv dy equal to according to the CRI equations. All right, so I'm teaching you how to remember these equations. So dv dy according to the CRI equations, we have right here du dx. So here we can put du dx. Okay, then we say integral. Then we're going to say plus. What is dv? We've already said dy, so now it's dv dv dx. All right, so dv dx according to the CRI equations right here, dv dx, we're going to have a negative du dy. So we're going to have negative du dy. Okay, so that is how you construct that, and you use this formula, and we are going to use this formula for question number 11. And in a situation where you're told to find u, you do the same thing. You say u, you're looking for u, of course. You're going to say u is equal to, what is du, okay, du dy. Okay, du dy will have a negative of dv dx according to the Cauchy-Riemann equations, plus du dx will have dv dy. So that is how you memorize these equations, and simply you just find du dx, you replace there dv dy, you replace there, you multiply by negative, then you integrate everything respectively, this part with respect to y and this part with respect to x. Same applies to this, and you are good to go. All right, let's solve the first example. All right, so the first example, we are given that v is equals to that. So we've checked that v equals to that is a quotient. So we can use either of, u is equals to that is a quotient. U equals to that is a quotient. So we can choose either of our Cauchy-Riemann equations. All right, so I'm going to pick the simplest one. I'll pick, okay, let me just write the equation first. We have v is equals to y over x squared plus y squared. So I'll pick the first equations. Sorry, why am I writing? This is u. U is equals to that, and we're looking for v, so I'm going to say dv dy is equal to du dx. And here simply I'm going to make dv the subject of a formula. All right, I'm going to make dv the subject of a formula. So my dv will be equals to, let me write properly, my dv will be equals to du dx dy. So I need to find du dx and plug it there, and we're good to go. So du dx, so I'm differentiating this with respect to x. I am going to have as my final answer, since I can do this in my head, I'm going to have 2xy all over x squared plus y squared, then everything squared like that. All right, since I can do that in my head, I'll just do there. Then our dv, use green, dv will be equals to, we replace what our du dy is, so we say negative 2xy all over x squared plus y squared, okay, everything squared, then with respect to y, okay, with respect to y. So from here I just integrate both sides, okay, meaning that my v would be equal to, okay, my v will be equals to the integral of negative 2xy all over x squared plus y squared squared with respect to y. All right, so what do I see here? I can make a substitution. I am going to let, hope you can follow it from here. All right, let me see. I am going to let b equals to what is inside here. So b equals to x squared plus y squared. All right, then now I find my db dy. Why db dy? Because we are doing with respect to y. So I find my db dy, all right? So I find my db dy because of that reason, and db dy will be equals to 2y. The goal here is to replace this dy with db so that we have a simpler integration there. So my v will finally be equal to the integral of negative 2xy all over, we say this is b, so all over b squared, okay? And now what is our dy? When we make dy subject of the formula here, we are going to have db over 2y, okay? When we make subject of a formula like that, then from here we see that the y and the 2 there cancel out, and we can factor out the x, so meaning that our v will be equals to negative x, because x is our constant in this case. Then we have b to the negative 2 db, okay, because x is a constant, we can factor it out. And yeah, so here integrating this, we're going to have v being equal to, b will be that, and simplifying, v will be equals to be positive x over b plus c, of which we know but b was equal to x squared plus y squared, so we can replace that back, meaning that our v will finally be equal to x over x squared plus y squared plus c. And we are done like that. So that is how we approach that one. Yeah, so I think just a comment that I would like to add. You'll notice that I didn't use this equation, though it would produce the same answer. But after making the v, you will reach a point where you're going to have x squared minus y squared over x squared plus y squared with respect to x. you're going to reach a stage where you have this. So if you're comfortable with integrating this, you can use this. It will require using trigonometric substitutions. So, but if you are not comfortable with this, you just change the equation that you are using. Then you go to the other one that will give you a simpler integration or integrand. So when you reach this point, maybe if you are not comfortable with this integral, you just go to this one that will give you the simple 2xy, and you make the substitution, and that will be that. So now from here, let's do the last one. All right, to keep it short, I'm going to do this one in the next part, so watch out for part 2.